Thanks very much. It's a great honour to be here as well. So thanks very much for having me. I was saying to Renata, one of my first conference presentations was a previous version of the APSRC, an APVI conference, talking about solar computer systems, and that's what got me into doing academia research for a while, and now I've come in through the back door doing an industry presentation again, but it's lovely to be back. There's a bit that I'm going to talk about today. I didn't know the timing when I proposed this title. With just 30 minutes, I'm going to cover a bit about flexibility, electrification and storage. But working at Endeavour now, I'll give you a bit of an insight of what we're planning for and the way that the electricity system's evolving and the role the distribution network has in keeping up with pace of all the great stuff that's happening with solar. I want to thank Uncle Billy for the welcome. I wanted to also acknowledge the lands with which we work and the network that we serve. So that's across the Wiradjuri, Darug, Yuin, Gundungurra and Dharawal country. This is also a helpful way of looking at our network map. So if you draw a line down from Parramatta north-south, that's basically the separation of our network from Sydney, and Ausgrid on the right-hand side up the north. And we work about 3 hours south down to Ulladulla as well. So that distribution network serves Australia's largest Indigenous population, urban Indigenous population of about 50,000 people in Western Sydney, but spread around those countries, spread around that country as well. For those that aren't from Australia, the distribution network system, we call them DNSPs, but distribution network service provider, is essentially about distributing electricity from 132 kVs down to customers. And we serve about 1.1 million connection points, or 2.8 million people in total. What's the solar story? There's been a huge drive from customers to install solar, and what we see here is pretty typical of Western Sydney now in terms of a suburb of Marsden Park, with over 60% of households having solar systems that far outweigh their daytime electricity usage. We've got about 29% of all of our customers with a solar connection, and it's growing at about 300 megawatts per annum as well, which is a really important success story for how customers are picking up and driving this energy transition probably faster than what's happened from centralised generation. On the home battery side, we've had the fastest uptake of the cheaper home batteries program that got announced by the federal government in July of this year, or announced in April and began working in July. But when you look at the postcodes, the top 10 postcodes for this program, we have the top 6. So it's a very popular movement in our area because people have a lot of solar and making better use of it. We also have the fastest growing use of electric vehicles in New South Wales, partly because of the distances that people travel. We're a commuting belt, essentially, for a lot of people in Western Sydney that commute into Sydney, as well as where I live in the Illawarra, striking distance with an EV. And with the more affordable EVs now, it's been a big uplift in terms of people taking these technologies on. If you want to have a look at how the energy use is changing with our networks, this is the 3 distribution network service providers in New South Wales, and a recent report we did called the Distribution System Plan, which really emphasises how the projected use of the network will change. We're in the middle there as Endeavour. Above us is Ausgrid, which serves a bit more of an urban population in Sydney. Higher growth of EVs, of course, and then Essential, which services the rest of New South Wales. And what's really interesting to see is that on an average usage, an average 24-hour basis profile, you see that change through the years out to 2050. Essential will be an average net exporter in the middle of the day from 2031, and we will be so in 2049. But this is not actually representative of what we're seeing at the moment. The future is already here, it's just not evenly distributed. Our Marsden Park site that we were just looking at in the last slide is actually more equivalent to what Essential's got in 2042 in terms of its average energy use now, and it flows from 16 MVA, MVA negative, so reverse power flow into the grid in its shoulder season, and only 6 MVA of consumption. So these suburbs are already net exporters in many cases. So how are we going to manage that change? This is what my team in the Future Networks and Markets look at in Endeavour, and it's all about making better use of customers' resources and trying to send the right signals and put in the technology layers to make this work and make it cheaper for everyone, really, because we can reduce volatility if we get rid of the spikes, and we can also reduce the energy costs for customers through electrification. So I'll focus a bit on smart solar, as this is a solar conference, but talk a little bit more about what we're doing with hot water orchestration to move that into the middle of the day, EVs, smart loads, and of course storage too. Before I get into it, I think one of the most important and understated things is what's changed in the regulatory context in the last few years. So as a distribution network service provider, we work on a 5-year planning cycle, and we sit down with the regulator and customers and we work out what projects we need to do in the next 5 years, and we get the agreement with customers on what the bill impacts of that will be, essentially. What happened in 2021, which was the year I joined Endeavour, was that the national electricity rules were updated to acknowledge that electricity flow was actually two-way, and it was really important that networks be given the opportunity to plan for reducing curtailment as well. It was also about the need for better cost allocations, and many in the room in the industry will probably know that that was the Sapin and St Vincent de Paul rule change that came through. A lot of it hit the headlines in terms of it being talked about as a solar tax, but what's probably less well known is that there's a really important fundamental business case that comes out of this, which is around how do we value solar that would otherwise be curtailed within the distribution network. And the AER essentially gave us a methodology and what they call a customer ex-watt curtailment value, which is a dollar figure for what a kilowatt hour of solar that's otherwise spilt is worth. We took our first inaugural DER integration and business strategy into that reg submission, so we're in flight of that at the moment, but we essentially valued what all the curtailment's worth, and then we went through the solutions on the right-hand side of how we fix it. So first of all, investing in low voltage visibility and analytics to better understand where these problems would be. Sorry, I'm just going to grab my water. 1 second. Oops. Don't forget that. And then we go through least expensive to most expensive, what we can do as intervention actions to fix these issues when they arise in the distribution network. So this includes tariff reform, that costs us nothing, but is actually a really important price signal to customers. Better use of hot water solar soaking, so orchestration of behind-the-meter load management, essentially. And then we actually go into fixing and changing the network, which is starts with phase balancing, so making sure that solar is evenly distributed across the 3 phases of the network, working to optimise the distribution tap transformer settings, so that's static changes on the transformers, moving into more dynamic changes in the transformers, what we call dynamic voltage management systems, and then last, when it's absolutely necessary, is actually making network investments, so that's upgrading distribution substations or investing in things like StatComs or network batteries as well. Finally, and this is what we'll go through in flexibility, is the DSO operations, so distribution system operations. And this is all about providing dynamic operating envelopes to the customers as well. All in all, this investment case for the 5-year period is about $80 million, and it unlocks about 6 terawatt hours of new solar capacity into the electricity system. So onto flexibility. As well as seeing the uptake of solar, we've also seen the sizes get really big, much bigger over time too. So in 2008, our average system size for a residential PV system was 3 kilowatts. In 2025 today, it's about 9 kilowatts. So systems have grown threefold. We've long held our static export limits at 5 kilowatts, which at a point in time was probably appropriate. But as we're reaching the intrinsic hosting capacity limits of our network, that would actually have to step down if we were still using static control and down to about 1.5 kilowatts. The alternative is to make better use of the data that we have from smart meters to start instigating dynamic limits, because a static limit doesn't make sense when the network capacity might be available for some of the year, just not in those peak events as well. So we've sort of seen these increasing grid issues move from voltage management problems to reverse flow on our assets. And now, as Daniel Westerman was saying earlier this week, with the transition plan for system stability, moving into managing minimum system load as well, which is about NEM system stability. So how this works in practice, on the left-hand side, we've got the household with the inverter. On the right-hand side is our systems. We start by using our systems to look at the smart meter data locally and the voltage to work out what the hosting capacity locally would be. We then pass that signal through to through a CSIP client to the solar inverters. The system then responds and then passes telemetry back to us as well. So this is a really big change in how we used to integrate solar. We would previously just let people connect systems and then let them run to essentially the available capacity of the solar. But what we're moving to now is actually having a constant real-time interaction, and that's really what distribution system operations is about. This is also the method with which we're going to be putting in the solar backstop mechanism, which AEMO has requested of us, which is due in July 2026. So all new systems will have to have this enabled, all newly installed systems. Previously installed systems are okay. They won't need to have this. But this is really about future-proofing the network. So what does this look like? What does this actually look like in practice for a real site? So this is a Ulladulla customer. In green there you see a negative number being the solar export from that site. The purple is the flexible dynamic operating envelope changing, and below that is the voltage at the distribution substation as well. So as you can see, when the times of the voltage exchange exceeding the limit, the constraint comes onto the solar system. So we're starting to make this work for 200 customers, including myself. From 2025, we've chosen customers that actually are already being capped at the 5 kilowatt limit that have larger systems. So they're all seeing this as upside, essentially. The system's been functioning well with about 99% of the time, over 99% of the time, people getting up to a 10 kilowatt static limit, so that's a good benefit for them. Connectivity, and I remember Renata telling me this maybe 5 years ago at Solar Analytics, has still been a big problem in terms of behind the meter connectivity with people's Wi-Fi, and that's a big problem and will probably create future issues in terms of people changing Wi-Fi passwords and what that actually means for us making this work. But it's really helping us understand what these new operational parameters need to be and what sort of support we need to give customers and installers as we work through this. That's a physical constraint. The other one that I mentioned at the start is also how we can send price signals. So Endeavour's updated with about 60% of our customers now having smart meters. It's actually a really good opportunity to update to time of use tariffs. On the left-hand side there is our tariff structure for consumption for residential customers. There's a midday period where we don't actually charge any distribution fees. The remaining fees there are actually the pass-on of TNSPs and the policy levers as well, so the levies that come through paying for the rent and other things. And so change between weekdays and weekends there. But also for exports, this is where we see the solar charge come up too. So starting to recoup some of the costs to implement these programs onto the customers that are actually creating the need, essentially. So there's a discount of the first, call it 3 megawatt hours per annum are free, so that's about a 2.5 kilowatt system on average. Won't actually see that need for the charge, but then above that, people will be charged 1.8 cents a kilowatt hour. But on the flip side, there's also incentives for people that can export in the evenings, and this is a network charge benefit essentially. So in the summer, that's 11 cents a kilowatt hour, and in the evening, that's 3.5 cents a kilowatt hour essentially. We'll be looking more at this in terms of the uptake and how this is passed on through retailers as well. Flexibility, solar is just one element. So there's also the hot water orchestration, which we've been working on for a little while now through our Off-Peak Plus program. We now have deals with 3 retailers who essentially are just taking over the hot water control and using it for market purposes, a market benefit. We think they're the best place to do that because the market benefit for them is much greater in terms of the value they can pass back to customers than it is for us. And it also reduces the cost of us providing that service through the meter service provider. We're also moving to a new world where connection applications, if they don't have sufficient headroom for a new site, we actually start sending them flexibility signals so they can have a firm rated capacity and then a dynamic capacity on top of that, which actually ebbs and flows as the capacity of the network is available. That'll be enabled by the CSIP client as well, as will public dynamic EV charging too. So we're just in the early phases of designing those trials now. Onto electrification. The more we can electrify and get more loads soaking up that solar in the middle of the day, the cheaper the cost for us on the network, as well as the cheaper the cost for customers as well. So it's a really important part. We've been running a pilot with Sol Griffith and the team at Rewiring Australia and our partners Bright2 to essentially take 500 homes off gas and into the future, probably accelerating the journey about 10 years ahead of what they would have done otherwise. Subsidies are available for induction cooktops, heat pumps, hot water systems and HEMS devices. We haven't subsidised batteries or rooftop solar directly because there's already existing subsidies which are making these customers' choices happen already, but we're trying to prove the complete picture of this in terms of what are the real bill savings and the activities of that, what's needed in terms of the installer base. It's a very different experience if you go to your electrician and ask for a cost to electrify your home. It's very different from if you went and asked for a solar quote. We're not quite at the level of maturity that the solar industry has been at, so trying to get those sort of issues sorted. From our perspective, Endeavour's involved to really take a close look at what electrification means for the distribution network. So we've done our first 60 homes at the moment, and we've just gone through a pilot review with Arena. We're now moving into the next 440 homes. As part of the program, we're putting in really high visibility on this part of the network. So it's one postcode, essentially, and we're looking at the increasing smart meter data, transformer data, upgrading our electrification analytics platform, doing the hosting capacity analysis, which I mentioned earlier, on a really resolute scale, and then making the interventions, as I mentioned before, about the regulatory framework, how we actually fix issues when they come up, only when they're required. But there's plenty of capacity in this part of the network, so we're not expecting too much cost to come out of that. We're also looking at how network tariffs can better place this, and this is a winter peaking community. A lot of our tariffs are set for Western Sydney, like our whole network. And so it's actually an interesting takeaway so far has been that just the need for local tariffs is going to be quite important to send that price signal for local management. In terms of the devices, you can see on the left there, these are how many people are taking up each of the respective devices. I would say that the lessons on the first 60 homes is that the market's still very immature in terms of what's the product offering here. There's a lot of preconceived biases around some of the installers of what they're trying to sell people and the best way to do things, and there's not much consistency. We found that the HEMS systems, the home energy management systems, which provide basically a control layer to the household smart devices, they've been really expensive to actually install, sometimes taking electricians to a day to 2 days to actually install and configure properly. So that's been a big barrier for us as well. I mentioned the winter peaking, but the other thing that I really emphasise here is the requirement about we're planning an electricity system for the future in the next 50 years, essentially. We don't have much information about the gas network connections and how that primary energy use will be switching over to reach net zero. So that's one of the things that I'm on my hobby horse a lot about at the moment, is trying to get access to that data and pushing the regulator to provide it to us as well. Onto storage. I'll just do a quick time check. Pretty good. One of the more important developments, I'd say, of the distribution system and storage, as well as connecting it for others, has been the development of this idea of community batteries. A community battery, for those that aren't familiar with it, we're using a battery in the first purposes for developing and supporting network needs, so using it to soak up that solar and to reduce peak demand in the evening. But we're also providing a layout which is for the retailers to offer customer benefits as well. So the intent of that is to really provide and address some of the inequities that exist for customers that either rent or don't have access to a battery because they may not own their own home or they live in an apartment. We've had one of the largest community battery programs. We started with a ring fencing waiver to do it across 10 sites, but then subsequently in the Albanese's first term, there was a promise for more funding for community batteries, and we picked up 2 rounds of funding, essentially now covering our network area. I'll come to the sizing in a minute, but 70 of these batteries are now installed and operating. We've probably learned a lot around deployment. I won't labour too much all of those lessons. I'm around for the next couple of days, so I can talk more about that in due course. But trying to really preserve what was the intention of that in terms of having a customer offering that has direct bill benefits for them. This has been the type of batteries installed, so 2 pole-mounted units, which are actually quite easy to deploy. So the Eco Stores are an EcoDual product. It's very easy for us to get them into the network and into the network where those that solar curtailment is highest because we can deploy these on basically any pole. With the ground-mounted units, these are a little bit less up into the leaves and branches of the project, of the network, and more in public parks. And you can see examples there of the Pixie unit, which is about 100 kilowatt hours, and our biggest is the Rolls-Royce MTU. There's some really useful information available from the Arena market snapshot, which has details of how all of the project costs are coming together for the different proponents of community batteries. We're sitting at about that dot there, so just below the line, but we've definitely chosen smaller battery sizes, which is probably not doing us heaps of favours in terms of economies of scale, but are helping us to really target that network constraint alleviation and get more solar onto the network. Some of the other important storage initiatives we're working on, getting faster at connecting third-party applications. This has been something that isn't really in the skill house or wheelhouse of our regular connections engineers, is to start planning what batteries need in terms of assurances of connectivity. We've done some grid-forming battery projects, including the Bawley Point microgrid, and we've got a new one coming with Colo Heights in 2026. Of course, there's EVs and the vehicle-to-home and vehicle-to-grid opportunities that are coming there. We're supporting a couple of the retail trials at the moment for home use of that. And virtual power plants, and to speak to the opportunity of virtual power plants before us now, this is a chart below of it from our connections portal showing the applications of residential batteries. And as I said before, the Cheap Home Batteries program was announced in March. Systems were eligible for connection in April, May and June, so long as they weren't switched on. And then July, they were switched on. So all of that growth has essentially been led by the policy and the subsidy that's available to customers. You can see the uptick in terms of the number of units going, but also the size changes. So a whole bunch of systems are now going in at 50 kilowatt hours, which is pretty incredible for average household use. There's a whole bunch of drivers, we think, behind that, both in terms of people wanting to get onto the Amber deals and not have to deal with the family dynamics of managing as if you're an Amber customer, I think. But also just people wanting to capture the most value out of the subsidy and the way that the market dynamics have worked with what makes sense for installers. So just wrapping up, and I think a minute or two. The way the conversation around what a distribution system operator does has been happening since the CIRO, AEMO and ENA, Open Energy Networks conversation, I think back in 2017-18. I think what's happening is that these functions are having to be adopted by DNSPs anyway, so we're really getting to the level of functional capability of DSO. It involves much better use of the data, making sure we're sending the dynamic signals, but also doing this in an end-to-end way that's holistic and looking at the overall system integration of that. I mentioned before these new investment cases. Every DNSP will have a CER or DER integration investment case. These are going to be really important artifacts that basically show how networks are responsible for integrating solar into the network. So it'll be really important to see how they go from doing this the first time, how that evolves over time, and what further changes we need to incentive structures to make that work. I think the research community has already demonstrated a really good way to lead in terms of standardisation of things like CSIP and the work at ANU's done in that space. And so I would encourage more conversation involvement to help with standardisation between us of the distribution networks and the TNSP interfaces. This is a bit of a finding from the Nelson review, which is going to be really interesting, is like, how do you make all of that behind the meter storage more market participative and not just locked up and not of value to both the market or the networks. So figuring out how to resolve some of those trust issues, but then the next step is really what's the correlation between market and network events. We're learning a bit about that with our community batteries at the moment, but what happens when there's actually tension pulling both ways, when the network wants to charge and the market wants to discharge. How do we better manage all of the uncertainty and forecasts of constraints as we move into a world of more dynamic connections? It's going to be really hard to manage as well, but trying to get customers to right-size their investments and look at what modular use cases might be available for them to plan in future as well. And then an obvious thing happening in the solar space and solar connectivity is what could you do to ramp solar down for negative prices and then share the benefits with both customers and the retailers. As I mentioned, there's a lot of missing information about primary fuel switching, so we want more information from the gas networks, and I think that's a really important next step. And there's the distribution system plan, which I mentioned at the start, is really about the role of the sub-transmission network and distribution networks. Could be actually a really important opportunity to avoid the need for quite slow and costly transmission investment as well. So what we call the missing middle, and there's another report which I'll direct people to have a look at. So that's my last slide. Thank you. Thank you.
Paul looks like you might run with the microphone if anybody has questions. Anybody? Questions? Terrific. Roger. Say your name, identify yourself before your question.
Thanks, Renata, and thanks very much, James. Roger Dargaville from Monash University. In one of your earlier slides, you showed the expected profile of EV charging.
Yep.
Now, EV charging is going to be critical. It's going to be a really big load in the grid, and most of your charging in those projections was during the day, yep, which is, of course, what we want, so it can soak up PV. But EVs, if they're being driven, are not going to be at home during the day. So I'm wondering if you can shed some light on what you envisage the EV charging infrastructure system to look like to be able to facilitate daytime EV charging.
Yeah, so when what was shown on that slide was probably the net of Ausgrids especially, was probably the one you're referring to. When we look at and plan the CER profiles and those sorts of things like charging profiles, we pick up the AMO ISP models, which comes from Cyro, and we use that. I think what's shown there is probably the net of impact of all of that EV charging across all of the sites, so whether it's public, for commercial and industrial use as well, which I think is going to be one of those challenges in terms of really getting the spike of that out. But I think those forecasts are very much the start of the hockey stick growth, and it'll be really important to understand the changes and sensitivities around that as it comes to reality and what the opportunities of vehicle to grid are as well. Yep.
I don't know if Paul's going to take another question. Very good. Okay. One of them was faulty. I might have the luck. I got lucky. There you are.
Wizardry. My name's David Mills. Very good talk, thank you. A couple of things. I'd like to know your view on the new government policy coming in July, where there's free solar in the middle of the day. And secondly, I have an underlying problem. We've been on these systems for many years. We have 2 EVs. We placed a lot of investment in the house doing this. And we are not treated in the same way that wholesalers are treated on the grid. And if you want a proper system where the prices rise according to the need in the grid, that should give the same benefit as a wholesaler to what is being gained by present large wholesalers. So I think having placed a large investment in these systems and getting very rewards, which have dropped about a factor of 10 since we started putting in some of these systems, I think you might get a better result by treating us as wholesalers so that we automatically match the load by the price that we see, and which has been abandoned with very low prices right now. I'd just like to know what you think about those 2 things.
Yeah, you're absolutely right. I think to one of your earlier points in that question as well, like customers have invested so much in this, and there's probably an economic rationality around the reasons for that. I think it's a great thing that's really pushed the transition forward. We're fortunate that they've done it, but the challenge that we have and part of the system challenges that we have in Australia is the way we've set up the market is each individual part of the value chain has to work within their own optimization. So the way that we set network charges, for instance, we set those up irrespective of what the market price is doing, and then we rely on the retailer to pick up those network charges, manage the market price, and then pass that on to customers. And there's lots of deficiencies in the way that they do that. They obviously play an important role in hedging and managing those things, but I think what you described is actually a bit of the symptom of every part of the system working separately and not to the holistic gain. And that's one of the challenges I think that we have in Australia and we need to sort of solve in this energy transition. But there's lots of different models that we might move to. I don't think the Nelson Review was particularly ambitious in terms of shaking up the whole system of the national electricity market and some of those charges. But yeah, I think that's one of the symptoms of just how we've sectionalised the parts of the value chain. Yeah, so we'll be looking. So as I mentioned, we don't charge the distribution part of our network charges in the middle of the day at the moment for those customers that are lucky enough to be on that. Only about 25% of customers are getting that tariff passed through to them. What we'll look to do in the now that DMO offer is coming effect next year, as part of our next tariff structure statement, we'll actually look to also spread over the TNSP and the policy levers that go across that so that there is actually zero charge for retailers, and we've talked to them about that. That will reduce some of the need for them to carry exposure to those prices in the middle of the day as well. But yeah, not all the networks have offered that gap yet. I think a lot of them will have to move to it in terms of managing it. It's not a perfect policy, I would say. It's good to see an intervention for bulk energy supply, but there's probably a lot of issues that come up for both solar installers that find it harder to sell a system, as well as the ramp rates that might occur on a time-based rather than what might be a more dynamic basis of availability.
Okay, thank you. Muriel. Okay, quick, Muriel.
Thank you, Renata. Muriel Watt from ITP Renewables. Thanks, James. Very interesting work you're doing. You mentioned just briefly in passing tariffs that are more localised or costs that are more localised. Are you able to charge different tariffs in separate areas of your grid, or are you obliged to have the same tariff charge across your entire network? And if you are allowed to do something at a local level, are you looking at how you manage local area within the network, and how are you looking at that?
Yeah, it's a really good question. So in terms of the ability to set local tariffs, I know that we do this for things like some of the community battery programs that we've rolled out with a particular retailer. There's been a local eligibility that comes out of that, and we can pass it through through that mechanism. So it is possible. I think what we're looking at for, and that's a trial tariff in particular, what we're looking at for the Electrify 2515 program is what the implications, like we're doing a bit of a deep dive on what an electrified future looks like for this community in the winter tariff. So how do we better set that up? The issue that retailers have with DNSPs is we all have very different network tariffs and the way we set up and interact with all of them. We're going to add another layer of complexity where we go down to the local level, and that will make their lives harder in terms of the churn. That's probably a barrier. It's not a reason not to do it, but that's going to be part of the challenges we face in doing that, I think. But that's going to be a really important part of that, I think, moving forward. But we'll just take ourselves a little bit further away from everyone being able to compare like for like, I think, too.
I'm going to stop now because we're going to run out of morning tea time if we're not careful.
Sorry.
Thank you, James. It's obviously a very interesting question. I have one comment to make. It's not a question, I don't want an answer, and that is, are you making the data available from what you're learning to university researchers?
Yes.
And I'm sure that there's a bunch of people in the room who would be very happy to work with you on a project or two. So, okay, great. Thank you, everybody. If you'd like to...